Hello everyone, today we're going to be talking about graphing polynomial functions. So polynomial functions can have all sorts of different degrees, like we've learned about linear, so it has a degree of 1, quadratic, cubic, quartic, quintic, and so on. And we see that the degree of a polynomial function affects several aspects of the graph. First, it affects the shape of its graph. Then it also affects the maximum number of turning points. And so that is the places where the graph changes directions. So for instance, for a parabola, the vertex would be a turning point because it's going from decreasing to increasing at that point. And then the degree also affects its end behavior. And the end behavior, that is just the directions of the graph to the far left and far right. And so we see 4 different types of end behavior that polynomial functions can have. The first one is up and up, and so that means that at the far left and the far right, the graph is going upwards. Next, we see a down and down. So for instance here, maybe we have a graph that looks like this, and at the far left and far right, it's going down. We have down and up. So that can be an example of down and up. And then we have up and down. And we can tell what the end behavior of a function would be based on the leading term ax to the n. And so we see n can be even or odd, a positive or negative, and whether it is one or the other, it's going to affect which type of end behavior you have. When a is positive and n is even, so the degree is even, the number in front of our leading term is positive, the end behavior here is going to be up and up. Now when n is even and a is negative, that is when we will have up and down. Oh, sorry, down and down. Now when n is odd and a is positive, we'll have the end behavior down and up. And when n is odd and a is negative, we'll have the end behavior up and down. And so we see this based on previous units when we were graphing linear and quadratic functions. Quadratic functions, so let's say I'll be looking at x squared, we see that the degree is even and the number in front, which is just 1, is positive, and we saw that that graph looked like this, and so it was up and up. When we had a negative x squared, we saw it went down and down, which follows exactly what we see in this chart. For linear functions, that was an odd degree. So like when we had y equals x, and we see when we graph that line, we start down and we went up because we had a positive slope, so we went uphill. Where we had y equals negative x, we have a negative slope, and so we went downhill, and we see that that is up and down. So let's look at some examples. So here I'm given the polynomial function, and I want to describe the end behavior of the graph. So I need to see, I'm going to be looking at my leading term, and so I'm looking at that term when written in standard form is first, so it has the highest exponent. So I see here that my leading term is this negative 0.5 x to the fourth, because x to the fourth, that has the highest exponent. And so I'm going to look and see whether my degree is odd or even, and my a is positive or negative. Well, my n is equal to 4, so that means it's even. And my a is negative 0.5, so that means it's negative. Remember, n stands for your degree. Your a is that number in front of your x to the fourth. So looking at my table, and I see when n is even and a is negative, the end behavior here is down and down. Okay, let's look at this next one. Next one I have f of x is equal to 0.25 x cubed minus x squared minus 1. So here my leading term is 0.25 x cubed. So my n is 3, and that is odd. My a is 0.25, so that is positive. And so looking at my table here, when n is odd and a is positive, my end behavior is down and up. Okay, looking at this last one, I have f of x is equal to 2x squared minus 4x cubed plus 7. Now this one is not written in standard form because my x cubed, that has the highest exponent, but it's not my first term. So I'm going to first rewrite this in standard form. And that's going to be negative 4x cubed plus 2x squared plus 7. And so I see my leading term is negative 4x cubed. So I see that my n is odd, because my degree is 3. And I see that my a, negative 4, is negative. And so looking at my table here, when n is odd and a is negative, my end behavior is up and down.